These are the frequently asked questions for Algebra 2 for Section 5-9, Day 2. Starting with number 24, we see that we're supposed to write a quartic function that has the given zeros as the only real zeros. Well, first we think, okay, all of this came from a factor, and the factors are x minus h or x minus k, depending on which section of the book you look at. But if we put a negative 3 in here, that'll be x plus 3. And if we put a 2 in here, that'll be x minus 2, but that's not enough factors. So we start thinking, if we have two real zeros, then the other two have to be imaginary. And we went through this in class where we would say that those two zeros are I and negative I, which would give us the factors of x minus I and x plus I. And whenever we do FOIL on those, we are going to get x squared plus 1. And so we talked about how we can go ahead and just use x squared plus 1 to make two more zeros that are not going to be seen because they're imaginary. So now we do have the 4 zeros that we need. And then we would go ahead and do FOIL on the back 2 and get x squared minus 2x plus 3x is plus 1x, and then 3 times negative 2 would be negative 6. Then we're going to go ahead and take x squared times everything in the second set of parentheses. So that will give us x to the 4th plus x to the 3rd minus 6x squared. And then take 1 times everything in the parentheses. And finally, we will go ahead and combine like terms. So f of x equals x to the 4th plus x to the 3rd minus 5x squared plus x minus 6. Then for number 31, it says determine whether each function can be obtained from the parent function of y equals x to the n. So they're saying, can we make these work in our a, h, and k formula? And with 31, the answer is absolutely we can by completing the square. And that's because we know we can make any quadratic fit by completing the square. In fact, there's only one of these up here that we're going to put no for, and that's number 30. So for number 30, if we try factoring this and we pull an x out, notice we have an x squared in the parentheses. You can't have that power inside the parentheses for our form. Sure, it'll graph as a cubic, that's not the issue. The issue is, can we talk about it with our a, h, and k transformations? And the answer is no. So number 30 is a no. But number 31, this one, we can go ahead and move the 7 over to the other side, because for any quadratic, we can always complete the square. And then we take our little formula of b over 2 squared, and that gives us negative 8 over 2 squared, which is negative 4 squared, which is 16. So we're going to add 16 to both sides, and that will give us y plus 9 equals x minus 4, the quantity squared. And then we would go ahead and move the 9 back over by subtracting. So y equals x minus 4, the quantity squared, minus 9. And then they said we were supposed to describe the transformations. So our transformation here, our h is 4. So this will be shift, you could also say, or translate. Shift or translate 4 units to the right. And then our minus 9 back here is to translate, and again you could say shift or translate 9 units down. And we have it. Then for 34, 35, 36, 37, 38, and 39, we are supposed to determine the transformations that were used to change the graph of the parent function y equals x cubed to each of the following graphs. To do that, what you might want to do is just go ahead and draw the graph of y equals x cubed. And that's a pretty basic graph, and it goes through those 3 points. And we can see here that they went by 2, so I want to be careful here. So our curve, our S-curve, would normally look something like that. So the first thing I notice is this is backwards. So that means that our A value was a negative. And the transformation that makes that happen is a reflection across the y-axis. So 35 said determine the transformations. Well, we would have a reflection across the y-axis. Now, it definitely looks like some things have changed here. And so I look at the center and I see that my new center for this graph is at 1, 1, and it used to be at 0, 0. And I think, well, how did they get the 0, 0 over here to 1, 1? Well, they slid it. They translated it. They went one to the right and one up. Shift 1 unit right and 1 up. But then I notice, even if we do all of that, that some of these other points wouldn't match. So I have to figure out what's gone on with these points that they're in different positions. So I see that I have my center at 1, 1, and I notice they give me a couple other points here. They're probably giving me those to help me out. So I look at 2, negative 1, and I think, well, gosh, where did that 2 come from? That just seems like it came out of nowhere. But I realize my original point over here that we put on this graph, it's a little bit higher than that, for our original was a negative 1, negative 1. And I think, well, how did they get that to be 2, negative 1? And we had the reflection, which made it go over to 1, negative 1. But that should have been it, unless they multiplied it by something. And what they multiplied that by was 2. So this has a vertical stretch factor of 2. So with this one, we would have a reflection across the y-axis. We would have a vertical stretch factor of 2. It would shift 1 unit to the right and 1 unit up. So you can use those as a way to do all of those problems.